Assalamu alaikum wa rahmatullahi wa barakatuh. Today our lesson is about congruence in right triangles. Okay, all of you, I want you to open the book page 258. Okay, let's see. In this lesson, you will prove that right triangles congruent using the hypotenuse leg theorem. Okay, so in this lesson, we will learn what is the hypotenuse leg theorem. I want you to look at this triangle, this triangle. Okay, look here. They put the mark on two sides. We know that if they put the mark on two sides, that means they are congruent. Is it right? And here, look at this. This angle. What is the meaning of this mark? Here, it's what? Right angle. Okay, so if this, in this triangle, if the angle is right, then we can call it what? We can call it as right triangle. Is it right? Okay, so I want you to look at this triangle now, and let's see here. Can you tell me what is, or where is the longest side? Where is the longest side? Name it in this triangle. In this triangle, name it for me. What is the longest side? Okay, the longest side is BC. Is it right? BC. This is the longest side. This is what we call it hypotenuse. Okay, so this is what we call it hypotenuse. And then this one is leg, and this is the second leg. So in any triangle, in any right triangle, or in any triangle, we have two legs and one hypotenuse. Okay, so let's see here. I want you to look at these two triangles. They put here that AC is 5. Is it right? It's 5. So what we can call this 5? This side, we can call it hypotenuse. Is it right? Because it's the longest side in this triangle. And look at this triangle now. PQR. PQR. Well, where is the longest side? Okay, we can say that this is the longest side. Is it right? They didn't give us the measure. But the question is, can we say that the two triangles are congruent by SAS or by SSA? Okay, so let's see here. Notice that the triangles are not congruent. So you can conclude that SSA is not a valid method for proving two triangles congruent. This method, however, works in the special case of right triangles, where the right angles are the non-included angle we took before. What is the meaning of non-included and included angles? Okay, so in this lesson, in a right triangle, we said the side opposite the right angle is called what? The hypotenuse, and it's the longest side. It's the longest side, okay? Always the hypotenuse is the longest side. And the other two sides are called what? The legs, okay? The first leg and the second leg. So let's see here. You can prove that two triangles are congruent without having to show that all corresponding parts are congruent in this lesson. We will take what we said, hypotenuse leg theorem. Okay. What is hypotenuse leg theorem? Let's see here. We call it HL theorem. H for hypotenuse and L for leg, of course. So let's see here. Theorem 4-6. If, look at the triangles. If they give you that the hypotenuse are congruent and one pair of leg is congruent and one pair of right angle is congruent, so we can say that the two triangles are congruent. Let me repeat it again. If the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Okay, so hypotenuse leg theorem, we have three conditions in this theorem. This proof of the theorem, just read it. It's not important to know. Let's see here, what are the three conditions for HL theorem? The first condition, there are two right triangles. The triangles have congruent hypotenuse. There is one pair of congruent leg. Okay, so if you find these three conditions in the two triangles, then you can prove that by HL theorem the two triangles are congruent. Okay, let's see next. Problem 1. Using the HL theorem, on the basketball backboard brackets shown below, angle ADC and angle BDC are right angles and AC congruent to BC. Are triangle ADC and triangle BDC congruent? Explain. Okay, so I want you to look at this triangle. Okay, they said here that angle D, angle ADC is right angle and angle BDC is right angle also. So here we have one pair of right angles. Is it right? Okay, and then they give you also that AC is congruent to what? To BC. And look, is it the longest side? Yes, it is. So here we can say that we have one pair of congruent hypotenuse. Is it right? Okay, so they said here the two triangles are congruent. By using the first condition and the second condition, we have to check for the third condition. Okay, tell me, look at this. This one, DC. What about DC? This side. All of you, you know that it's congruent to itself. Is it right? So DC, we can say that DC is congruent to itself. So here is also one pair of congruent leg. Is it right? Congruent legs. So here, by the first condition, the second condition, and we found the third condition, so we can say that the two triangles are congruent. Got it? By what, of course? By HL theorem. Okay, let's see next. Got it, number 1. Here they give you this question that angle PRS, this is the angle PRS, and angle RPQ are what? Are right angles. Is it right? They put already the marks. And then they put the mark here on what? SP. This SP is congruent to QR. Okay, and I want you to look at this. What we can call this? We call it, of course, hypotenuse. So we have one pair of congruent hypotenuse. Is it right? And we have also one pair of right angles. So we still have the third condition. What is it? Can you find it? Okay, so here, this is the first pair with the red and the second with the purple. So what is the third condition? We can say that PR is what? PR is congruent to itself by reflexive property of congruence. Is it right? So we can say that PR is congruent to itself. So this is the third condition. So we can say that the two triangles are congruent by HL theorem. Let's see question B. Reasoning. Your friend says, suppose you have two right triangles with congruent hypotenuse and one pair of congruent legs. It doesn't matter which leg in the first triangle is congruent to which leg in the second triangle. The triangles will be congruent. Is your friend correct? Explain. Okay, so let's recall what we took before in HL theorem conditions. The first condition is to have one pair of right angles. The second is to have one pair of congruent hypotenuse. And the third condition is to have one pair of congruent legs. Is it right? So we didn't say which leg exactly. So that doesn't matter. Okay, so here, is your friend correct? Yes, he is. So this is the answer for the first question. Question 1, letter A. And this is for question 1, letter B. Okay, let's see next. Here we have problem 2, writing a proof using the HL theorem. Okay, given here, BE bisects AD at C. Okay, so from the word bisects, think about it. You will understand what. And then they give you here that AB is, what is this symbol? This is for perpendicular, is it right? So if you see this symbol, you will understand that the angle here is what? Is of course right angle. Got it? This one. And then they wrote here also DE perpendicular to EC. So the angle is what? Is also right angle. So we have here one pair of right angles. And then they give you that AB is congruent to DE. Okay, so here this is also what? This is also what? We have one pair of congruent legs. Is it right? Okay. So now let's see. From the word bisects, you can understand that BE congruent, BE bisects what? Bisects AD in which point? In C. Is it right? This point. So this BE bisects AD at this point. So you can understand that from the word bisects, we said that the bisector always divide the segment into what? Into two equal parts. So you can understand that this CD congruent to this AC. Is it right? Okay, so we have now, let's repeat. We have now one pair of right angles and one pair of congruent legs and one pair of what? Of congruent hypotenuse. So we have the three conditions. Then the two triangles are congruent by what? By HL theorem. Got it? Okay, let's see next. Got it, number 2. Here given that CD CD is congruent to EA. And this is what? Hypotenuse, is it right? And then they give you that AD is the perpendicular bisector. Okay, so from the word perpendicular bisector, perpendicular, you will understand that what? The angles are right angle, is it right? The angles are right angles. So here, this is right, and this, of course, right, even if they didn't say, but you know from the word perpendicular that the two angles are right angles, okay? And then from the word bisector, we know that the bisector divide the segment into what? Into two equal parts. So AD, this one, bisect CE, this one. Okay, AD bisect CE. So you can understand that this leg is congruent to this leg. Is it right? So let's recall now. Let's repeat what are the conditions. The first one here, the yellow, are what? Hypotenuse, is it right? So one pair of hypotenuse. And then here, the red. What is the red here? It's for what? One pair of right angles, is it right? And then here, the blue, one pair of congruent legs. So we can prove that after proving the three conditions, we can prove that the two triangles are congruent by HL theorem. Okay, let's see here the last question in this lesson, page 261, all of you. Error analysis. Your classmate says that there is not enough information to determine whether the two triangles below are congruent. Is your classmate correct? Explain. Okay, so let's check. We said we should have three conditions to prove by HL theorem. Is it right? So let's check. Here we have the first one. This is the first pair. For what? Right angles. Is it right? Okay, and then the second condition, this one and this. So we have one pair of congruent leg. Is it right? Do you have the third condition here or not? Tell me. Of course, yes. We have the third condition. It's LJ. Here, this side, we know that it's congruent to itself. LJ is congruent to itself. So, and this is also the hypotenuse. So we can prove that the two triangles are congruent. Why? Because we have three conditions. The first one, right, a pair of right angles. The second one is a pair of congruent legs. And the third one, the one we found, one pair of congruent hypotenuse. That's it for today. Thank you.